Hi everyone, this is the video on section 5 of chapter 1 in geometry. We are going to look at segments and angles and their measures. How long are the segments? What's the degree of the angle measures? Those kind of things. That's what we're going to look at in this section. In order to figure out the length of a segment, we have to know how we can apply numbers to points. And every point on a line can be placed in a one-to-one correspondence with a real number. So it can look something like this. Here is a number line, and I have placed 5 points on this number line, and each point corresponds with a real number. The point is designated with a capital letter. Its number value is designated with a lowercase letter. So point A is a capital, but the value of A is -8, so A is -8. Just to get the idea, when we're talking about its value, what the number corresponds to that point, but then we use the lowercase. If we're referring to the point itself, we use the uppercase. Not a huge deal if you forget that, but just so that you don't get confused. Okay, so how do you find the length of a segment? How long a segment is, because it has 2 endpoints. So the length of a segment is the distance between its 2 endpoints, and you find distance by subtracting. So it's the difference of the number value of one with the number value of the other. You just subtract. Notice here, though, that I put this in absolute value symbols, because distances are always positive, never negative. And so what you do is you take the value of one point, subtract the other. It doesn't matter which you subtract from which, and then make your answer positive, and that gives you how long the segment is. Another term that we want to define is absolute value. And this might seem a little bit confusing to you, but I'm going to explain it because you're going to see this in the text and I want you to understand what they mean. So the absolute value of x, the absolute value of any number, that's this, is just that number. If it's 0 or positive, then it's just that number, nothing changes. Because remember, the absolute value is about distance. How far is this number from 0? And distances are never negative. Now the reason this says negative x, if x is to the left of 0, or negative, because negative means the opposite. So if my number is negative, it's the opposite of the negative, or positive. That's why it's defined that way. So if you see something like this on a quiz or a test, that's what they mean. And the reason is because absolute value is the distance from that 0 to that number. Okay, let's go back to this number line that I gave you earlier that has 5 points plotted or graphed on this number line. Notice when I graph number lines, the number values are below the line, the names of the points are above the line, and the points are designated with a strong point on the line. All right, the first segment that I want to find is BD. So if I want to find the length of segment BD, then I need to find the value of B, which is -5, and the value of D, which is +2. And remember, to find the length of a segment, I am going to subtract. So I could go -5 minus, because I'm subtracting, D, which is 2, the absolute value of that. So the absolute value of -7 equals 7. What if I went the other way? What if instead of going B minus D, what if I went D minus B? Let's try that, because D is 2. So I went 2 minus, and B is -5, -5. Remember, if we subtract a negative, it's the opposite of a negative. It becomes a positive. 2 negatives make a positive in this case. 2 plus 5 equals 7, and the absolute value of 7 is just 7. So you get the same answer. It doesn't matter which direction you go. Why don't you take a minute and try to find the length of segment AE. Pause the video, figure it out, and then restart it and see if you got it right. Okay, I hope that you got A is -8 and E is 3. That's -11, so the answer is 11. How did you do? Okay, let's do one more. Find the length of segment EC. Pause the video again, figure it out, and then restart it and see how you did. Okay, I hope that you got E is 3 and C is -1 minus a -1, which is 3 plus 1, or the absolute value of 4, which is 4. How did you do? Okay, let's learn about the term congruence. So congruent segments are segments that have the exact same length. So if you notice, this is segment AB. It is 3 centimeters long. This is segment CD. It is also 3 centimeters long. So the segment AB is congruent to the segment CD. Notice in the illustration, AB and CD both have that little red line through it. That's a congruence mark. Excuse me. That signifies that they are congruent to one another. Here is our symbol for congruence. I would say that segment AB, and there's my symbol for segment AB. Remember that straight line over AB is congruent to, and the symbol for congruent is an equal sign with that little curly over the top. I have no idea what that curly over the top is called. But in any case, if I put that over the equal sign, that is congruent symbol. So AB, segment AB is congruent to segment CD. This is the symbol that we use when we're talking about figures, in this case, segments. I know they're congruent because they have the same length. If I want to just talk about the length of AB, which happens to be 3 centimeters, then I don't use the segment symbol. I just will write AB. That means the distance between A and B, or the length from A and B. And because that refers to 3, now I will just use the equal sign. The length of AB is equal to the length of CD. Segment AB is congruent to segment CD. Do you see the difference? It is slight, but we want to be as precise as we can so that everybody knows what we're talking about. Okay, let's talk about another postulate. This is called the segment addition postulate. So I have drawn this big segment. It has 3 points on it, A, B, and C. The length of AB is 5. The length between BC is 3. So AC is 5 plus 3, or 8. The segment addition postulate says this: if B is between A and C, then AB plus BC equals AC. It's just that this is common sense. You don't have to prove it. By the way, the converse is also true. If AB plus BC equals AC, then B is between A and C. So you know that if that's true, then B has to be between A and C. And this works if B is between A and C. So that's the betweenness thing we talked about in the last section. Now B is between A and C, but it's not right in the middle, is it? If it was right exactly in the middle, then it would be a midpoint. So let's talk about midpoints next. Okay, here's another segment with 3 points, X, M, and Y. And now I'm going to tell you that M is the midpoint. It is the midpoint if M is between X and Y. So there is an order of X, M, and Y. And XM is equal to MY. Notice I marked that with these red tick marks to show you that those two segments are equal. Therefore, M is exactly in the middle between X and Y. Okay, I've drawn on a board an example of the kind of problem that you can get dealing with segment lengths and dealing with betweenness and all that. So we have this segment with points A, B, and C on it. The length of AB is 6x minus 1. The length of BC is 5x plus 10. And our task is to find AB and BC. Notice those don't have the segment symbol because I'm not finding the segment, I'm finding the length of AB, the distance between A and B. That's what I'm looking for. Anyway, I'm told AC is 75. So based on that information, how am I going to set up an equation to solve this? And in this case, I'm going to use the segment addition postulate because I know that AB plus BC equals AC. This part plus this part will equal the whole thing, and I know the whole thing is 75. So I'm going to write my equation, 6x minus 1, minus 1, make sure I do that right, plus 5x plus 10 equals the entire segment, which is 75. And now I remember my algebra skills from last year and solve this, so I'll combine like terms. I have 11x plus 9 equals 75. And then I will subtract 9 from both sides. I'll get 11x equals 66. And then I'm going to divide both sides by 11, and I get 11 equals 6 because 11 times 6 is 66. I said 11 equals 6. X equals 6. But that's not what it asks. So if you write x equals 6 on your answer, you will wonder, well, why did you mark it wrong? Because x does equal 6. And I'll go, yes, you're right, but that's not what it asked you to find. It said find AB. So once you find the value of x, then you plug it in. So put 6 back in for here. 6 times 6 is 36 minus 1. AB equals 35. Now plug it into 5x plus 10. 5 times 6 is 30. 30 plus 10 is 40. BC equals 40. Double check. Is 35 plus 40 equal to 75? It is. Now, so we got it right. Good. That's how we check our answer. Now we can answer this question. Is B the midpoint? Are 35 and 40 equal to each other? No, they are not. So we say B is not the midpoint. That's an example of the kind of problems that you will get and that you will solve. I took the same problem and I just changed it around, and now I'm going to tell you that B is the midpoint. I'm just going to say that. So if you get a problem that says, given that B is the midpoint, now find AB, BC, and AC with that knowledge. So now what would you do? If B is the midpoint, then that means these two segments have to be exactly equal to each other, because the fact that it's the midpoint means it cut it exactly in half. So I'm going to set up my equation that AB, or 6x minus 1, has to be exactly the same as 5x plus 10. That I just make an equation with the relationship that I know exists. Now I solve for x. So I'm going to subtract 5x, and x minus 1 equals 10. I'm going to add 1, x equals 11, and now I'm going to plug 11 into x, and that would be 66 minus 1, or 65, and 11 times 5 is 55, plus 10 is 65. So these are both 65, and the whole thing then would have to be 130 because I would add those together. So look at the relationships to understand how will you set up your equation to solve the problem. Okay, now let's shift to angles. In angles, if you want to measure how wide an angle is, then you can put the two sides of an angle on a protractor. Instead of a straight ruler, you would use a protractor, and then you could measure one-to-one correspondence with the two sides to figure out how long or how wide or how narrow your angle is, knowing that 360 degrees is a complete revolution. Protractors are 180 degrees, so you could measure any positive angle that's 180 degrees or less, just like you would with a ruler. A protractor is a ruler for angles. The angles are measured in degrees, and you have that symbol to the upper right of the number. Angles can be classified into four basic categories. We say angles are acute if their measure is between 0 and 90 degrees. Then they are acute, and you can remember that because they're just a cute little angle. They are right if they are exactly 90 degrees. They form a perfectly square corner. They are obtuse if they are larger than 90 degrees but less than 180 degrees, then they are obtuse. And straight angles are exactly 180 degrees, or they're basically a straight line. Okay, angles can also be congruent if they have the exact same measure. So if we want to mark, or you see in a diagram that angles are marked as congruent, they are marked with this little curved angle symbol. In the textbook, they will be marked in red. When you're doing your homework, it doesn't have to be red. It can just be a regular pencil. It doesn't matter. But those two with that same kind of curve marking means they are congruent. So you would say that angle X is congruent to angle Y. And there's our angle symbol. And since I'm referring to the angles, I would use my congruent symbol. Now they are congruent because they have the exact same measure. If I want to refer to the measure of angle X and angle Y, which is about 45 degrees, then I would say this. I would say the measure of angle X. So that lowercase m in front of my angle symbol stands for the measure. The measure of angle X is equal to the measure of angle Y. I'm referring to the number value, so now they are equal. I'm not referring to the shape, so it's not congruent. You see the difference? So that's how you say congruent angles are congruent, or their measures are equal. Earlier we talked about the segment addition postulate. The exact same principle applies with an angle addition postulate, which basically says because I have this ray in the interior of this larger angle, then this smaller angle, like angle 1 plus angle 2, would equal the larger angle. So if this was angle ABC, then angle ABC would be equal to angle 1 plus angle 2. So it's the same idea with angles as with segments. So copy that in your notes. So that is the angle addition postulate. So here's an example of a problem that we will get needing to use those principles. Here is a diagram. I have, that should be a D. There we go. Notice these markings, these congruent symbols. So earlier I showed it just one arc, showed that they're congruent. So sometimes you can use 2 arcs or 3 arcs. The double arc here shows that angle 1 and angle 2 have to have the exact same measure. This tells us that the measure of angle 1 is 55 degrees. Based on that, what is the measure of angle 2 and what is the measure of angle BAD? Since the diagram says angle 1 is equal to angle 2, then if angle 1 is 55 degrees, guess what angle 2 has to be? Also 55 degrees. Angle BAD are angle 1 and 2 added together, so to find the measure of angle BAD, I just need to add 55 plus 55, so its measure should be 110 degrees. That's how you do it. Again, this section has an extensive list of vocabulary words for your notebook. So go ahead and put those in there to help you out for quizzes and tests and homework. And I will see you guys in the next section.